Good day. Today we will be talking about the general classes of fertilizers. There are two classifications of fertilizer, the organic fertilizer and the inorganic fertilizer. Organic fertilizers are fertilizers that are capable to be decomposed and which contain varied amounts of nutrients. Example of this is animal manures or droppings. Green manures is from leaves, legumes, grasses, and rice straw. And the third is compost plant and animal materials. So here is an illustration of how organic fertilizers works in the pond. So the fertilizer provides nutrients, and then the nutrients through photosynthesis is absorbed by the aquatic vegetation. The aquatic vegetation composed of the phytoplanktons and the vegetal cover and any higher plants that is present in the area will be eaten by both the lower aquatic animal or by the fishes. The lower aquatic animals is composed of the zooplanktons, the swimming fauna, and both bottom fauna. And if the fishes dies, the dead matter will be decomposed by bacteria and will provide again nutrients to the aquatic vegetation. So here is the average composition of several manures. We have the manures of poultry, sheep, fattened cattle, dairy cows, pig, or hogs. So here we can observe the water content and the nitrogen content, the phosphate, then the potassium. So here is a table of estimated daily production of farm animal waste. So inorganic fertilizers are fertilizers that are not decomposed but rather dissolved in water, in which concentrated amounts of at least one of the three major plant nutrients, in which is the NPK, stands for the nitrogenous, phosphate, and potassium. So here is an illustration of how inorganic fertilizer works in a pond. So the fertilizer chemical is dissolved in the water, after which it will be received by the phytoplankton, which the phytoplankton will absorb the nutrients and store it. As the fertilizer descends, it will be embedded in the mud, in which there will be an exchange of nutrients and will set the production cycle of the nutrients. So here is the classification or types of inorganic fertilizers. First is the single element fertilizers. These are those which contain only one fertilizer element. So here is an example of a single element fertilizer. In our nitrogenous source, we can use urea, and for a phosphate, we have these phosphate stones. And for our potassium, we can have potash. So this is the second classification or type of inorganic fertilizers. The incomplete fertilizers. These fertilizers is the fertilizers that contain only two types of fertilizer element. These fertilizers contain only nitrogen source and phosphate source. Determination of amounts of fertilizer nutrients and of the required absolute amount of fertilizer. The last slide, shown the Sechi disk, is a very simple tool which can be used to give better estimate of the turbidity. It is particularly useful in green-colored pans to estimate the plankton turbidity. This measurement is then called the Senchi disk transparency. How to determine the available amounts of nutrients present in given inorganic fertilizer. So the formula is the weight of the nutrients available equals the weight of the fertilizer times percent of the fertilizer nutrient available for use. So example number one, we have 50 kilograms of urea that contains 46% of nitrogen. So keep in mind that the percent of the nutrient should be in decimal. So we have here 0.46 times 50 kilograms is equals to 23 kilograms of nitrogen. So if we have a 50 bag of urea, we simply deduce or minus the 23 kilogram nitrogen. We have 27 kilogram of filler. So in the other problem, if we have an incomplete fertilizer, which is the ammonium phosphate, that contains 16% nitrogen and 20% phosphate. So we simply multiply the given, which is the 50 kilograms times 0.16 in nitrogen, will have 8 kilograms of nitrogen. And in the 50 bag, we times the point 20 is equals to 10 kilograms of phosphate. We simply add the given nutrient, we'll have 18 kilograms of nitrogen and phosphate. Then we minus the 18 kilograms of the available nutrients to the 50 kilogram bag. We'll need 32 kilograms of filler. In complete fertilizers of 50 kilogram, we have 14% nitrogen, 14% phosphate, and 14% potassium. So we'll do the same in the previous problems. We'll just multiply the nutrient available to the bag, the total kilogram of the bag, which is 50 kilogram times 0.14 is equals to 7 kilograms of nitrogen, and 50 kilograms times 0.14 of phosphate, we have 7 kilograms of phosphate, and in potassium, it is the same, 7 kilograms. So the total nutrients weighed, both the NPK is 21 kilograms. We minus the total weight of the sack, which is 50, so we'll have 29 kilograms of filler. So how to determine the required amounts of inorganic fertilizers with a given recommended or required treatment or dosage? So there are two approaches here. Option one is the formula is amount of fertilizers, this is in kilograms, equals the recommended treatment or dosage of nutrient in kilograms, divide over percent of fertilizer nutrient available for use in this decimal. Option 2, this is solving in bags. So the amount of fertilizer equals dosage of nutrient in kilograms times 100 over the weight of the fertilizer bag times the percent of fertilizer nutrients. So here, example number one, the recommended dosage is 40% of nitrogen. I think there is an error here. This should be 46. So for option number one, we shall solve it in kilograms. So here we have the recommended dosage is 40 kilograms of nitrogen over 0.46 available fertilizers in urea. So we just divide it and we'll have 86.96 kilograms of urea. In option 2, we'll solve it in bags. So the recommended dosage is again 40 kilograms of nitrogen times 100, you have 4,000, and 50 times 46% of nitrogen in urea is this. This is in decimal. This is in whole number. So 50 times 46 is equals to 2,300. So we'll just divide. So we'll have 1.74 bag of urea, or 86.96 kilograms of urea. So here is an example of how to solve incomplete fertilizer. So here we have a recommended dosage of 30-20 of NPK. We only have we have two sacks of one urea and one incomplete fertilizer, which is the NPK here is 46, 16, and 20. So first we will solve the incomplete fertilizer, which is the 1620. Here the dosage is required for the phosphate is 20. Then the percent of available fertilizer is in, this should be in decimal again. So it's 0.20. So so 20 divided by 0.20 is 100 kilograms 1620. So here we have 100 kilograms times 0.16 of nitrogen in 1620. We have 16 kilograms of nitrogen. 100 kilograms times 0.20 is 20 kilograms of phosphate. So here we just minus the dosage and the given 16 kilograms of nitrogen divided by the available nitrogen, which is in the urea. So it's 14 kilograms divided by 0.46 is equals to 30.43 kilograms of urea. So in summary, there are 100 kilograms of 1620 and 30.43 kilograms of 46% of urea. The total of 130.43 combination of ammonia phosphate and urea back. So here in the second, we can solve it in bags. So we need 20 kilograms of phosphate, multiply it by 100, and the available bag is 50 bag kilogram times 20% of phosphate in the 1620. So 2,000 over 1,000 is 2 bags of 1620. So this is a continuation of the past slide. So we know that we need 2 bags of 1620. Now 2 bags times 50 kilogram bags is equals to 100 kilograms. So 100 kilograms times 0.16, because this is the available nutrients in the 1620 bag. So we'll have 16 kilograms of nitrogen. And the second one is 0.20 times 100 kilograms, so it's 20 kilograms of phosphate. So here we minus the recommended dosage to the given nitrogen level is so it's 14 times 100 is equals to 1,400 over 50 kilogram bag times 0.4 times 46 is equals to 22,300. So we divide it. So we'll have 0.61 bag of urea, or 30.43 kilograms of urea. So in summary, we need 2 bags of 1620 and 0.61 bags or 30.43 kilograms of urea. So here we're gonna solve the complete fertilizer. So the problem has the recommended dosage of NPK is 20, 10, and 4 kilograms. The available fertilizer of urea is 46, and we have the ammonium phosphate of 1620, and a complete fertilizer which is 14, 14, 14. So here in option 1, we have the recommended dosage is for 4 kilograms of potash. So we'll minus it in we'll solve it in the 14, 14, 14 bag. So 4 kilograms divided by 0.14 in 14, 14, 14 complete fertilizers is equals to 28.57 kilograms. Also, we're gonna solve the nitrogen and the phosphate in the 14, 14 bag. So we'll arrive at 4 kilograms of nitrogen, 4 kilograms of phosphate, and 4 kilograms of potash. Now we'll solve in the 1620. We'll minus the zero point 0.4, which is in the 1414 bag, to the phosphate. So 10 minus 4 is 6 kilograms divided by over 20.20 phosphate in 1620. So 6 divided by 20 is equals to 30 kilograms of 1620. So we'll solve the nitrogen and phosphate in the 1620 bag. So 30 kilograms times 0.16 is 48 kilograms of nitrogen, and 30 kilograms times 0.20 phosphate is 6 kilograms of phosphate in 1620 plus 4 phosphate in 1414. So in now we'll solve the nitrogen. Here, so we're gonna solve the nitrogen level. So the recommended dosage is 25 kilograms of nitrogen. We'll minus the given nitrogen in the 1620 and the 1414 bag. So 4 plus 4.8 kilograms of nitrogen minus the 25 kilograms is 16.2. So we need the urea bag has 0.46% of nitrogen in the urea. So 16.2 kilograms of nitrogen divided by 0.46 nitrogen in the 46 bag is equals to 35.22 kilograms of urea. So in summary, we need 28.57 kilograms of 14-14-14 bag, 30 kilograms of 1620, and 35.22 kilograms of urea.